Alrighty, it's 1 after the hour, so we will get started. So we had a pretty late agenda. I asked a couple of folks to talk about some projects. So Tom, do you want to start off talking about the save send feature, and then we'll also talk about the ZStandard work, and then if there will probably be time after that if folks have other topics that they'd like to discuss. Tom?
Can you hear me?
Yep, go ahead.
Yep, sorry. Reinstalling Windows messes up with Zoom. But anyway, basically, I wanted to talk a little bit about a feature which I originally called partial sends, but which for a few reasons has now been, the name has been changed to saved sends. I guess I'll just start out with kind of the real basic overview of what the feature is and why we wanted it. Basically, the idea was we have, in our data center, we have a bunch of storage nodes, which all have a bunch of data sets on them, and they back up to a secondary data center somewhere across the country. And traditionally, we have done this backup with ZFS send, which we do to files over SSH. We basically pipe ZFS send to a compressor and pipe that over SSH to a file on the remote side, and then we uncompress that file and receive it. And the reason that we do it like that is because in the past, we haven't had resumable sends. Then we moved to resumable sends, and that was a lot better because now we don't have to write all the data out twice. We don't need to write it once into the file and then again into the data set. So that was a big improvement, but we started looking at some of kind of the edge cases of how that kind of works in our cloud. And one of the edge cases that we ran up against was the concept that sometimes we have a node that, for one reason or another, for hardware failures, for various reasons, pretty much mostly hardware failures, but basically what will happen is we need to kind of get the data off of there in whatever state that it is. And what we realized is that if we have a primary node which we have put all the data on, and it has, I'm sorry, if we have the secondary node which we are putting in the process of putting all the data on, and we do a resumable stream, we don't have any way to get that partially received data set off of that node and onto another one that is healthier. Basically, the idea is saved sends is the answer to that, and basically the idea is it allows you to do a ZFS send of an incomplete data set or a partially received snapshot. Basically, it takes everything that has been received up to the bookmark and it sends that. From an implementation standpoint, which is kind of the bit I want to get into a little bit, it's actually really pretty simple from a conceptual standpoint. Basically, if you do not send a DRR end record in any send stream, and on the receive side, if you receive with the resumable receive flag, as presumably you were going to anyway, you basically end up with a stream that's resumable, even though you haven't gotten everything. Originally, we implemented this in kernel space, where basically within the kernel we kind of deciphered the bookmark, and then we did some basically maneuvering to reinterpret what data set was actually being sent, because the to good was correct, but the name of the data set might be wrong, and a few other things like that. So basically, we originally did all that in the kernel space, but after looking at some of the kind of edge cases and stuff with redacted sends, what we realized is that it would be a lot cleaner if we just took if we did pretty much all the processing out in user space. So basically, the way that the implementation works right now is is basically the user space module. It goes and it gets the resumable receive token that normally would be used to to tell the remote side how to resume the send. And instead, it just kind of restarts that back at 0. It just kind of rewinds it, and then it changes the name of the data set back to whatever that partially saved data set is. And then we just basically do the send from there. And in the kernel, the only real change there is we don't send, like I said, the DRR end record for partial sends. So I was actually pretty pleased with how cleanly it fell out, and it seems to be working. We're moving to use it in production pretty soon, but it has gotten through a bunch of testing, and everything seems to be okay with it. The one other bit of it that I will mention before I can answer any questions that anybody might have is included in this patch is the ability to resume a receive, to resume a saved receive from a bookmark, which is very confusing to think about. But basically, the idea is that if you were in the middle of this saved send procedure and then that got interrupted, you can still resume this as well. That's really all that kind of means. So you can resume a saved send from a bookmark. That's kind of all I had. Other than just I wanted to kind of get a feel for the room in terms of whether or not people were okay with it being implemented in kernel space or user space. Like I said, we originally did it in kernel space, and then we kind of remaneuvered it to user space. But I was wondering if anybody had any specific kind of concerns about that or thoughts.
So just to make sure I understand, like the use case, and to reiterate, like you're talking about you're doing a receive onto your like secondary system, and then you realize like, oh, this system that I'm receiving onto is actually dying, so I want to like replicate everything from this system to another one, like a third system, and you want to do that before you have like completed the receive that's running on the secondary.
Right, and the big reason for that is because that first, like all of the data coming into our primary data center, that's all bandwidth that our partners, like all of our customers, actually have to pay. So it's a lot slower. Some of our, like famously, the example we have within Datto is that we have one partner who is on a boat, and they just run their like appliance on a boat, and that like when they get to dock, that's when they kind of back everything up. And other than that, it goes over like a satellite modem. So it's very, very slow. So we kind of designed for that use case. Yeah, so the idea is we didn't want to make the partner, because we had a node dying on our end, we didn't want the partner to pay that bandwidth price again, and kind of make the whole thing transparent to them so that we can maintain our data center, kind of transparently.
Gotcha. Because in that model that you're describing, the primary that you're doing the send on is actually like on the boat, right?
Yeah, exactly.
Gotcha.
Right.
And the secondary is like the machine that you're actually operating that is in your data center, but it might be failing, and so you want to be able to like ZFS send everything off of that system to like a third system,
right.
But you haven't completed the receive from the boat.
Yeah, exactly.
All right, that makes sense to me.
Yeah.
So did anybody have any questions or thoughts about that? I can put the pull request in GitHub. I'll bring it up right now. But if anybody wants to take a look at it, please feel free. We're looking for a couple more reviewers, although it's been approved by Brian, I believe, at this point. So,
I did
but we
go
are
through it.
still obviously, we're always looking for more reviewers on these kinds of things.
Yeah.
I'll take a look. Paul, do you have any plans to look at this?
I already took one look at it, but I will take another look at it.
Okay, cool.
And I'm putting the link for it in the chat right now.
Cool. Yeah, in terms of like the kernel versus UserLand, like where it's kind of figuring out what to do. I mean, I'll take a look at the code, but it seems like, on the one hand, like having UserLand do it is kind of like, it feels a little bit like UserLand is like tricking the kernel into doing what it wants. But on the other hand, like probably the implementation is nice and simple and with minimal kernel changes, which seems like that's valuable too.
Yeah, the other thing is, I think from my perspective, is that we kind of want it to trick the kernel. That's kind of like that's kind of the goal, is because we want a send which basically looks, it basically kind of looks and feels like it's coming from that original system. Yeah. But we just want it, because we want the exact same send file. Basically, we kind of want to make sure that nothing gets reinterpreted or anything like that. So yeah. I think tricking the kernel isn't necessarily a bad thing, even if it wasn't originally designed for that. It seems to fit the use case pretty well. I do see a couple of questions in the chat which I had not noticed before. More like replicate partial receives, I think. Yeah, pretty much. That's exactly it. We want to take a partially finished receive and replicate that to somewhere else. Given A, replicate to B, replicate to something else, would this allow you to start replicating from A to B, or from B to blah, blah, blah? I'm not sure, actually. I have not tried it for that use case. My gut feeling says no. The question for those of you who aren't looking at chat is basically, can I use this to start sending part of a data set to someplace else before it's finished being received? I don't, again, what I was getting at is I don't really know. We haven't really tested it in that case.
Yeah, I suspect that there's a check when you go to do the send.
Yeah.
That you weren't also in the middle of a receive.
Yeah, because I think it gets owned is the big thing. I'm not saying that this isn't possible to do.
Yeah, you might be able to do this with the extension, but it probably doesn't just work.
Yeah, I would think that. Yeah. Jordan says no resumable token yet. I'm not 100% sure what you mean by that. But I don't know if you want to join the voice call.
No, it's okay.
Okay. Well, that was my spiel. So.
Yeah.
Cool. Thanks, Tom.
Thank you.
And oh, by the way, did you have you sent out a message to the OpenZFS developer list just to let folks on make sure that folks on other platforms know about this?
I have not. I can do that. Is that I was kind of not aware. Is this, and maybe this would be helpful for everybody else. Is that kind of what we're doing with new features? Is like trying to put them on the mailing list? Yeah,
I think we talked about this at one of these meetings like several months ago. But just since I mean, this is probably a little bit less of a concern now with FreeBSD, joining together with the ZStandard, but just to make sure that like folks on Alumbos and other platforms are aware of all the upcoming features. We were asking folks to just send an email to the OpenZFS developer mailing list, and just be like, hey, we're working on this new feature. Here's a link to the pull request, to make sure that all of the relevant experts have a chance to weigh in, even if they aren't necessarily following every ZOL pull request.
Okay. Yeah, I can definitely send out an email, tonight or tomorrow about that. So, yeah.
All right. Any more questions about that? All right. The next on the agenda, I'm probably going to mispronounce your name, so I apologize in advance. But Kjeld, or why don't you tell us how to pronounce your name, and then talk about the ZStandard work, which I'm very interested in hearing, like what the status of that is and kind of what you think we need to do to get this completed. Oh, let's see. So he said that he couldn't find a microphone. He posted a message in chat.
You want to read it out, perhaps?
Yeah, I'm going to read out the part after the preamble. So a lot of work has been done on ZStandard in the last few weeks. Sebastian, who goes by the Brainslayer handle, has completed the majority of the design, and a lot of testing has been done. And then he said that he, Sebastian, and also Michael, who goes by Code Zero, are working on finishing cleaning it up, restructuring, documenting, and some work on compliance with the ZStandard library itself. If you have any input or want to do some testing before the final PR, please help us out. And the PR number is 9673 is their work in progress. Cool. Yeah, too bad you couldn't find the microphone. I guess I was interested in maybe Brian, maybe you know some of this background, but the history of we've had several different ports or forks of forks of forks, and several different PRs. If you or anybody else has some background on that and kind of what we need to do to move this forward, I'd love to hear it.
Yeah. So I have some of that background. At least I can try to summarize my understanding. Like you say, there have been a couple of versions of this out there. And I believe the current work is to try and bring those existing versions together in one pull request. And that work is ongoing in the new pull request. And it's mainly in need of reviewers and feedback at this point. I know they've been iterating on it a lot. But I'm not sure if Alan and Brainslayer are both commenting on it. So I don't have a lot to add, but I think this is basically an intent to pull all that work together into something we can get merged.
Cool. All right. Kjeld said, the current restructuring work takes the best parts of the two major forks, Alan's one and Brainslayer's one, and I guess combines them together. So that sounds great. I guess I and other interested folks should take a look at the final PR when you have that ready. I think you mentioned to me that should be in a few weeks. So hopefully by the new year that'll be ready for review. And it sounds like do you know? I know Alan. I see Alan's not on the call. Do you know, is Alan on board with this new PR superseding his old one, or should we talk with him about that offline?
I don't know for certain. We should definitely touch base with him if he's not on the call.
Okay, cool. Well, maybe between now and the next meeting, either Brian or I plus Kjeld and Alan should have an offline conversation. Kjeld said that he tried to get in touch with Alan, but wasn't able to. So we'll see. We'll try to make it happen so we can make sure everyone's on the same page, and then hopefully we can move forward with this new version as soon as it's ready, which should be very soon. Cool. Any more questions or comments about ZStandard work? All right. Then I guess we'll just open the meeting to any other topics that folks wanted to discuss.
I had one.
Mm-hmm.
So basically, and I apologize because I haven't been at the last meeting or two, so maybe this is stuff that we've already talked about. But so a feature request came in today, or it's been around for a little while. But basically, the feature request is to allow encryption to work with dedup across multiple data sets. currently encryption works with dedup within what I call a clone family. So basically a data set, its snapshots, and any clones of those snapshots. That's all nice and everything, but some people have asked for the ability to be able to also do that across different data sets. That is possible, but the drawback there is that it is not cryptographically possible then to separate those data sets in the same way that all data sets normally are kind of are separated. So normally, like, each data set is kind of encrypted on its own, and the fact that they share a user key is kind of just a management layer. This would mean that they'd need to have the exact same actual master encryption key, which is kind of hidden from the user. The two things I wanted to ask on this were, one, what are people's opinions on this kind of thing? Because there's a couple of different takes on it. One is, if this is, if you don't ever want them to be separated cryptographically and you want them to dedupe like that, why not just put all of the data in the same data set? You could kind of ask that question. Maybe some people like that just from an organizational perspective. They like the idea of having different data sets for different things. And maybe they already have code to deal with that. But I kind of wanted to just get a feel of the room in terms of, what people's thoughts on that kind of issue are. Did I explain it clearly enough too? Because
yeah, I think so.
I kind of hope I did.
I mean, to me, it seems like as long as we can make it clear what's going on with the user interface, then it seems fine.
How would they get the same key? Like you would.
It would have to be a special ZFS create flag or something where basically you
use the same key as this thing over here, basically.
Yeah, and I mean, like, there's some bits about that I, to be honest, haven't really completely thought through. So, for instance, like originally, I was thinking this would be like you'd have to have the same key as your parent.
Yeah, I assumed you'd have an inherited key only.
Well, but if you're inheriting, right, then you're in the same clone family at that point.
No, if you're inheriting, you are not in the same clone family. So that's kind of like a little thing that's a bit complicated. So every data set that, like, if you're not in a clone family, you have a different key from everybody else. But the user key, so the key that you actually provide to decrypt the data set, that can be shared, and that's what the encryption hierarchy, that's what defines the encryption hierarchy.
So this would be kind of the opposite, right? In that the interior key, the key that you encrypt the things on the disk with, would have to be the same, but the user key could be, the wrapping key could be different.
No, because if cryptographically, if the internal key is the same, or what I call the master key is the same, then it doesn't really make sense to allow people to have different user keys for it, because then cryptographically, if I know the password to one data set, I can decrypt the other. So, like, that's kind of, if we
that would be surprising.
Yeah, if we set it up exactly. So if we set it up so that you could do that, because I mean we could do anything just from a management perspective, but that would be, that would definitely cause people to end up in situations where they don't understand what's encrypted with what keys.
Okay, so we would be creating a new.
It's kind of like create like today. So I guess first of all, just in case it wasn't clear, the clone family that you're talking about is like all of the data sets that are related by cloning and snapshotting. So,
right.
You create a clone of some snapshot, then now that clone and the thing that you created it from are part of the same clone family because they share.
Because they're using the same block pool,
exactly.
basically. And
like
then a child data set is not part of that family because it does not share.
Right.
Okay. So today the only way to get the key into the child data set is through inheritance. Is that correct?
But
so
when
but it's
user key, but not the master key.
Right.
Right. Yes.
Right. So the
I
child
see.
data set will have a completely different master key. So if you want to decide later on,
we generate those randomly at data set creation time.
Yeah, every
And then
time that you do a ZFS create of a new data set that is not a snapshot or a clone, you get a new master encryption key.
And we wrap it with the same wrapping key.
Right.
Okay. So we would be creating a new relationship of some kind where there'd be a property on a data set that says I use the user key and master key from this data set over here.
Right.
Yeah, could you do this with like the inheritance, where you could do something like, when you create that first data set with the encryption on, there's some encryption property that's that says like everything under all of my child file systems get exactly the same. Not only are they encrypted, but they have to use the same
master key.
Master key, and therefore obviously the same wrapping key as well.
Yeah, that might be the easiest way to do it, and the way to do it without breaking a ton of code that currently exists. Because if we allow you to kind of link to arbitrary data sets in a pool, that could that can get very complicated in terms of like when you go to move stuff. Right now there are a bunch of checks that make sure that you're not moving anything outside of its encryption root, and those checks could get real complicated if we if we complicate these rules all too much.
Would we add a new property to an encrypted data set that just selects the key inheritance style for new children, or would we add a flag of some kind to the create operation?
I think it would be a new, if I had, and again, I'm literally coming up with this right now as we're talking, but I think it would be a new property, kind of like what Matt was suggesting, where you say like, you have a property that's like shares key equals true. And then like on top of that, that gets a little complicated as well, because then you have new inheritance rules for that property that you also need to adhere to. None of this individually is all that crazy, but like, if you are saying like, I share a key with my parent, like that I guess would that just be a regular inheritable property? Would all of your children then get it? Could your children unset it? There's kind of some complications.
One, do you allow people to set that property when the data set in question already has children that do not have that kind of inheritance in place?
Yeah, see, like that's another thing. And it definitely can only be set at creation time, because your encryption key gets created or gets set up only at creation time.
So I think it sounds like there is interest in this, and like if we can design this interface in a way that makes it so that people can understand what's going on and not get not shoot themselves in the foot in terms of their protections, and also not make undue restrictions on what things they can do with the data sets, then it sounds good. We probably aren't going to be able to totally design that out in this meeting, so maybe it makes sense.
I think my only concern is making sure that we don't accidentally make it harder to do the right thing by default from a security perspective, basically.
And I think that's kind of like I know we spent a good amount of time talking about like what it would actually look like, but I think the thing that I kind of wanted to get coming out of this was, it sounds to me like we think it's a good idea to allow, like it's a reasonable idea to allow this and to add this feature, whenever I or somebody else gets the time to actually implement it. But I'm not hearing anybody saying like, no, that doesn't make any sense to do. That's not a.
I mean, if you already think dedup is a good idea, this is probably fine too, right?
Yeah.
I guess.
This is just for dedup, basically.
As far as I can tell, that's the only use case. That's the only thing where this kind of matters, because that's kind of the only thing that changes by having this kind of broken relationship.
Would you restrict this to only be used if they also have dedup on?
Oh, that's a whole other question.
That kind of goes to shooting yourself in the foot, right? Which is
maybe, but then like you can turn dedup off, right?
But you can still have a DDT when you turn it off, right? Like
yeah, and you still have a DDT. You do still have a DDT, but you can also turn dedup on, right?
Yeah.
And you need to specify this at creation time.
And today you could turn it on with the encryption as it stands. It's just that it wouldn't be dedupe amongst your children, right? That's the
correct. Yeah,
okay.
Right now you do not dedupe amongst anything outside of your clone.
Yeah.
So
the use case Steph was asking about, I assume that at least one use case would be like, I have a bunch of disk images that are in different ZVols, and they're all, each of them has similar contents because they're all, Windows installs or whatever, or backups of the same system into different ZVols or something like that. And then they want to, and they're already using dedupe today. That's deduping between these different, totally independent ZVols from ZFS's point of view. And now they want to have encryption, and encryption is going to break the dedupe between these different.
Right, they're doing VDI or something, and now they want VDI with encrypted data at rest.
Yeah.
I guess I could see how that would be a thing.
Yeah, I mean, we don't use dedupe or encryption, and I'm glad that at least we don't use dedupe. but it does seem like a thing that people use ZFS for.
Especially with metadata allocation classes, I think it got slightly less crazy.
Yeah, performance.
Provided you have the right devices.
Yeah.
Yeah, the guy who filed the pull request was saying that basically for his use case, he has a lot of images which look really similar, the VM images that look similar, and he gets better performance by using dedupe because they can share the ARC memory. So when he tries to boot all of them at once, you're not doing as many disk reads.
All right, so that's the dedupe user. Okay.
The one. Yeah. Okay, but I'm not hearing any like significant pushback other than we should think this through. So.
Yeah, I think thinking it through really needs to underscore that it's not going to make what works today with the crypto and the soundness of that crypto any worse. Basically, I think that's that would be the gate.
And I mean, like, I think the easiest way to do that is just make it behave the way it currently does by default.
Right.
And this is like a setting that, again, I'm going to say this one guy, but really anybody who's using dedupe and who's currently using dedupe across multiple data sets and wants to add encryption to that. Yeah. Okay. Thank you.
Cool. What's the next topic of discussion? All right.
So I can make a call. Well, yeah, I got one thing maybe. If we have other people who are interested in this functionality, there has been work that is ready for review to port the persistent L2 ARC to Linux. So there's a pull request open for that now that has test cases and is ready for reviewers. So we should probably mail the Lumos list to let people know that it's out there for review. It's a port of the work done for an Accenta.
Is that Sasso's thing?
Yeah, it's a port of Sasso's thing. And it's there and it's ported, so I don't know of the status of that on other platforms. But if there are people interested in that work, please take a look at the pull request. It's 9582.
Cool. Yeah, I will add that to my list as well.
Have we had, I apologize for being absent for one or two of the last calls. Has there been a recent status update on how the FreeBSD integration stuff is going?
A recent one? I don't think so, but it's going well. Last I checked. I haven't looked at the FreeBSD exactly, but I believe most of the kernel changes have been integrated at this point on the Linux side.
Matt says there's 4 files left to go.
Okay.
So we're getting close. There's still some bigger changes on the user side outstanding, I believe. There's a pull request outstanding to update all the test cases to be FreeBSD friendly. And then another one to drop in all of the FreeBSD code. But I'd say the bulk of the refactoring has been largely done, and we're hoping to wrap it up in the next couple of weeks to a month or two, depending on how long it takes to get everything, like passing all the tests. But expect big additional chunks to get merged relatively soon.
Fair enough. I think we're going to continue holding off, waiting for that before we take a serious swing at getting it to build on Illumos again, I think.
Okay. There are still a couple more passes to refactor things
right,
to make it as much common code as possible. So some of that is going to be disruptive to Illumos. There was some work done, fairly invasive work done recently to pull out a lot of data structures that are Illumos specific and replace them with like a ZFS equivalent. Things like the vnodes in particular were pulled out of all the common code. So I'm sure that'll be a little disruptive.
Cool. More topics? Going once? Going twice? You'll notice I did not introduce the meeting by saying that we have a late agenda and we may end early. So, you know.
Because you're smart.
Yes, because I'm smart. And so this week, finally, we do actually end early. So
there you go.
Enjoy your next 20 minutes. And the next meeting will be 4 weeks from now on January 7th. And it's going to be at the the new, even earlier time.
4 in the morning?
Yeah, I forget what time we agreed on. I need to go look at I think the notes are in the doc. Move the early meeting time to 9 a.m. Pacific instead of 11 a.m. So it's going to be, this one was at 1 p.m. Pacific. So it's 4 hours earlier than this meeting was. In whatever time zone you are in. Cool. So thanks everyone, and have a great holiday and New Year, and we'll see you in January.